So, today we're going to be discussing area. Now, I want to take a brief moment before I get into the notes to discuss what area actually is because it's caused some confusion in the past. Area is whenever I have a shape. Let's say I got a shape that looks like this. And we're trying to find out how much space this shape takes up. The way that we do that is we can break it down into little squares, each one of these squares being 1 by 1, and then count up all of the squares, including each of these partial squares like this, this, and this. Now, actually counting these out is hard because we're not sure how much of a square these fractions of squares are. So instead, we're usually given formulas to help find the area for us. That's what we're going to be using today to find the area of a plethora of different shapes. So as we go today, make sure you write down the equation so that you have access to it later. That being said, you will also have access to a formula chart in the future, so as long as you can find it on there, you should be fine. Let's go ahead and get into the notes. Example 1, I have a square. Now, the formula for an area of the square is as simple as it gets. Base times height. The base is what my square sits on. The height is the height of the square. All I got to do is plug in the values I have to where they go in the formula. So I would say the area is equal to base is 8.5 times height, which is 8.5. You could also write this as 8.5 squared because they're both the same number. Regardless of how you write it though, 8.5 times 8.5 is 72.25. Now again, we've discussed this in the future. I'm finding the area of a shape. So my unit needs to be feet squared. Because whenever we're counting up the area, we're counting up all those little squares. So it is feet squared. This is the formula for a square. For a triangle, the formula is going to be 1/2 base times height. The base of my triangle is the 15. The height of my triangle is this dashed line. If I ever give you a number for the diagonal, that is not my height. That's the diagonal. The height specifically goes from the tip of the triangle, dropped down to the base. So my height is 21.3. All I got to do is plug in the numbers and then let the calculator do the work. 1/2 base is 15 times height is 21.3. Now something cool, this 1/2, because of that, I can actually write the equation like this if I so desired. 15 times 21.3 divided by 2. And whenever I enter that into the calculator, I should get 159.75 units, in this case, are meters squared. If you leave off the meters squared, you're going to get points counted off. Make sure you have that. Make sure you write down the formula for the area of a triangle and the area of a square before you move on. If you still need to write it down, go ahead and pause the video. Otherwise, here we go. Example number 3. This shape is a parallelogram. We know it's a parallelogram because opposite sides are parallel to each other. Meaning if I extended these lines in each direction, they would never cross each other. Because of that, I can use this formula. The area of a parallelogram is actually the same as the area for a square, base times height. The hard part in this is trying to find out what the height actually is. The base, again, is what my shape sits on, so it would be 12.9. The height, just like with a triangle, is not the diagonal piece, but it's this piece here that drops straight down. This is my height. Now that I've got my base and my height, all I got to do is plug it into the formula. Area equals, the base is 12.9, the height is 7.1. Multiplying those two things together, I get 91.59. The unit is inches squared. Make sure you write that down. If you've got any questions, I wish I was here to help, but I'm not. Example 4. This is a trapezoid. It's a trapezoid because the top and bottom are parallel to each other, but these other sides are not parallel to each other. So we have one set of parallel lines, one set of non-parallel lines. So we get to use a different formula. The formula for the area of a trapezoid is 1/2 base 1 plus base 2 times height. Now this one is a little bit complicated, so make sure you understand. Base 1 and base 2 are the top and bottom of my trapezoid. They're the things that my trapezoid can actually rest on. They're the parallel pieces. So if I'm labeling this shape, I'll label this base 1 and this base 2. Now lucky for us, it doesn't matter which one is base 1 and base 2, so long as these two pieces are my bases. For the height, it's not going to be 16.5 or 21 because those are the diagonals. Just like the last few shapes, the height is the part that drops straight down and forms a 90-degree angle with the base. This is going to be my height. Now that we've got everything identified, we can plug it into the formula. The area is 1/2. Base 1 is 19, plus base 2 is 27, times the height is 16. Now, again, just kind of like the triangle, if we wanted to, instead of writing 1/2 here, I could write it as all of this over 2. Whichever way we write it, we're going to get the same answer. Whenever I plug this into the calculator, I get 368 centimeters squared. Don't forget your unit, or else you're going to get half credit. Again, before we move on, make sure you have at least the formulas written down for the shapes. If you have the formulas, it's as simple as finding what pieces are which and plugging them into the right place. Moving on. Example 5. Here I've got a triangle. Even though it looks a little bit oblong, it's still a triangle. Again, the diagonal is never my height. So, make sure you don't use that as your height. Instead, the height is the part that drops straight down. This would be the height of my triangle. This would be the base of my triangle. And the formula is 1/2 base times height. So, let's go ahead and put the numbers where they belong. Area is equal to 1/2. Base is 29.5 times height is 14. Again, if you'd like, you can write it as all of this over 2 instead of the 1/2 in front. Regardless of how you write it, when you plug it into Desmos, you should get 206.5 inches squared. Example number 6, you'll see I've got half of a circle here. So the formula I'm going to use for the half of the circle is very similar to the formula for the area of a circle. The area for a circle is pi r squared, correct? Well, because I have half a circle, I'm going to divide my area by 2. So the area for half a circle is pi r squared divided by 2. My radius is given to me here, and that's the only variable I need. I can go ahead and start plugging it in. The area is equal to pi times 17 squared divided by 2. Plugging it into the calculator, I should get 453.96 feet squared. Now these next two are the hardest ones, so please make sure you're paying attention. Example 7. I've got a trapezoid again, and the area for a trapezoid is 1/2 base 1 plus base 2 times the height. Base 1 and base 2 are easy enough to find. This is base 1, this is base 2. The height is not going to be 10. Instead, the height is going to be whatever this distance here is. So the question becomes, how can I find out what this distance here is? The way that I do that is by using triangles. I know you don't like triangles, but they appear quite frequently in geometry. Here's what we got to do. We're going to treat this as a triangle and use Pythagorean theorem to find out the missing side. We'll call it h. First, we have the diagonal here. We need to find out what this distance here is. And we're going to use the bases to do that. Here, this is 7 centimeters long, which means that this portion here is also 7 centimeters long. So what I can do is I can do 19 minus 7 and get 12, and then split it into 2 equal pieces to find out what each distance here and here are. So I can take that 12 and divide it by 2. Getting 6 for the bottom of this triangle. Now I can use Pythagorean theorem to find out the missing height. We're going to call the diagonal C. We're going to call this space A. We're going to call H, H. Remember, Pythagorean theorem is A squared plus B squared equals C squared. My A value is 6. My B value, we're going to call the height. My C value is 10. 6 squared is 36. H squared, we don't know what it is, so we're going to leave it H squared. And 10 squared is 100. And we just need to solve this out for H. Ask yourself, how do you get rid of a positive 36? You've got to subtract 36 from each side. How do you get rid of a square? What's the opposite of a square? The square root is how you get rid of a square. The square root of 64 is 8. So the height of my shape is 8 centimeters tall. Now I have everything I need to actually find the area. So I'm going to go ahead and plug it in. The area is 1/2 base 1 plus base 2 times the height. When I type that into the calculator, I should get 104 centimeters squared. Now that one was fairly difficult. If you have questions about how we found the height, that's okay. I'm going to be back in class tomorrow and we can discuss it a little bit more in depth. Otherwise, ask yourself if you have any questions about this. The goal was just to find base 1, base 2, and height. The journey to height was just a fairly difficult one. Example number 8 is a word problem. So let's go ahead and go through it piece by piece and see if we can find out how to solve it. It says a triangle with an area of 45.5 centimeters squared has a base that measures 14 centimeters. Find the height. Okay, well, I'm given the area of a triangle. So let's start with the area of a triangle. We have that formula up here on our page. The area of a triangle is 1/2 base times height. Looking at our problem, I want to pull out what information I actually have. The area is 45.5. I have the base is 14, but I don't have the height. So we're going to call it x. Now what we got to do is we've got to plug this in to the formula and solve out for the missing variable. The area is 45.5, so I'm going to replace a with 45.5. 1/2 stays 1/2. The base is 14, but we don't know the height. The height is going to be x. Now we're going to have to try and solve this out. There's many different ways you could do this. Right now, the easiest way to do it is notice that 1/2 is getting multiplied by 14. So we can ask ourselves, what's 1/2 of 14? 1/2 times 14 is 7. So these become 7, and I can drop down the x equals 45.5. The last step, I've got 7 times x. How do I undo times? I've got to divide both sides by 7. So 45.5 divided by 7 gives me 6.5 for my x. So my height is 6.5 centimeters. Remember, only area is centimeters squared. Right now I'm finding the height, so the unit is just regular old centimeters, not centimeters squared. If you have any questions, try and rewatch the part of the video that you're confused on, and if that doesn't help, hold the question until tomorrow when I get back into class. Otherwise, be good for the sub, please.